Um, I guess I just go ahead and start talking. I'm going to go ahead and share my screen, and we will be, well, maybe. Here we go. Finishing up the program evaluation lecture, I want to go ahead and apologize for not being able to do it at the appropriate time. Hopefully that is working and you can see it. It's up on a different screen here and still trying to figure that out. Okay. All right. Oh, time for me to speak up. All right. So what we're going to be talking about here is essentially how researchers can address all those problems that I talked about on Monday that face certain types of research. And yeah, okay, I can't even see myself, but that's okay. Hopefully this is working out. So we looked at those things at all these problems that come up anytime you can't randomly assign people to a treatment group and a control group. So it's the randomization that allows us to control for all this external stuff that we have no control over, and allows us to rule those out as potential causes of, say, a change in behavior. So what do we do when we can't? Well, first we're going to start with the details of what an actual experiment looks like, and then go for how we approximate it. There's a couple of things just in general about planning evaluations that are very important to understand. The first one is whenever a new program or policy is being put into effect, is being implemented, there should be a predefined systematic evaluation strategy in place. There's lots of reasons for this. One of the big ones just is to make sure that you're going to get the data that you need to evaluate the effectiveness of the program. The other one is it does help you limit bias down the road. If you can get it set up in a neutral scientific way at the beginning, then kind of no matter who takes over, and I'm thinking here about politics and bureaucracies and how all of that works, then the evaluation should still be done consistently, and therefore keep its scientific validity. Of course, this almost never happens. Not almost never, but it doesn't happen nearly as much as it should. There was actually a very positive trend during the Obama administration where a lot more of this was put into place. They even had a website called performance.gov that allowed you to track evaluations of policies, and you go on there and you could see, like, here's a specific goal, here's what we've found out, or here's what we're doing to find out. And so it was part of the whole transparency aspect of certain parts of governance under the Obama administration. And we've seen that periodically over time, but generally speaking, it doesn't happen nearly as much as we should. So, again, we're facing a situation of real world research where we're not going to necessarily always be able to do an experiment where it's not incorporated in the original plan. And so we're having to go back in time and just kind of hope that we can come up with a strategy and that we can find the data that we need to answer the question of whether or not a particular policy works. And I just want to point out, I'm going to go through some kind of archetypes of different evaluation strategies. Lots of times these things are used in combination with each other. You don't just have to do one. You can layer them on top of each other, essentially trying to cover up some of the potential problems with one strategy with some advantages of another. So just keep that in the back of your mind, because at times you'll probably be like, well, couldn't that be a time series? And yes, is the answer. Um, but again, we're looking at sort of ideal types. So we'll start with the gold standard. Um, that is a randomized experiment. This is what most of the hard sciences do when they're making their discoveries. You see this a lot in psychology, um, though how random they are. It mostly has to do with the selection bias problem and some of the psychological ones, and who it is that is volunteering essentially to be a part of the experiment. There's also issues with the sample being representative, since a lot of the people who do these experiments are college students like you. Um, but anyhow, as much as we can, we want to uh, use experiments because they are really the only way that we can directly claim causation. And by directly, I mean without the use of inferential statistics. Um, we can just use descriptive statistics to say that it caused this, at least in the people that were in the experiment. Um, so here are some of the key characteristics of experiments, and without any one of these, it's not truly an experiment. So random selection, obviously, is number one. The researcher has to have the ability to manipulate the variables of interest. So in the policy world, this would be to actually adopt and implement the policy. You can see where that's potentially problematic pretty immediately. Um, there has to be consistency in application, meaning that whatever it is that they're doing to somebody or giving to them, that the process is the same for the treatment and the control groups. This is why that idea of a double-blind study can be important, because there's no way that some kind of implicit bias can enter in the evaluator um, if they don't even know who's in the treatment and who's in the control group. Okay, so consistency. This is why if you've ever uh, been given a survey or participated in any of this stuff, people tend to speak with almost a robotic voice, and that's again trying to be consistent, not having any kind of you know sort of interesting changes in tones of voice and that kind of thing that might in some way affect how people answer. Okay, and the last one is it has to be repeatable. Okay, a single experiment does not create knowledge. Um, we have to know that um, this is true, and it's true at different points in time, with different groups of people, and that kind of thing. So repetition is super important. We saw this actually with a meta study done by a group of, I believe they were social psychologists, um, who, I'm going to just pause for 1 second if I can figure it out. Okay. Um, going to pick this back up. Sorry, I had to answer a quick text from my mother-in-law, who was wondering if I'm actually at home today. Um, all right, so get back to where we are. Repetition. So there have been all these fascinating experiments done, again, mostly in college students, in the field of social psychology and psychology in general. Um, and a lot of that is part of the behavioral economics literature as well. Um, but there was always some concern that these studies weren't being repeated. And this is true of all kinds of academic studies. The bottom line is there is almost no personal incentive for researchers to try to duplicate other research projects because they don't get published. And if you are a tenure track professor, even a tenured professor, you're trying to get your research published. That's how you get tenure. Um, and so most journals don't publish this kind of stuff. Most researchers don't do it. Um, but this group of social psychologists and psychologists went back and they tried to repeat something like 130 experiments, some of the most popular experiments. Um, and they only successfully recreated the results in like 20% of them, or something like that. My numbers could be a little bit off here, okay, but the lesson is still the same. Um, Even some of their own experiments, ones that they had originally done themselves and published, they tried to do it again and they got different answers. So without that repetition, we don't truly know that something is true. So it is absolutely crucial to the scientific process, and has to be an attribute of an experiment for it to be that. Um, so all of these things together, or at least the randomization and the control thing, right? That allows us to make causal claims. We're able to rule out competing pathways, competing uh, variables. Um, so obviously that's good because we need some sort of causal claim. Um, when it comes to policy research, a couple things just to be very aware of where problems often come up in this type of research. The first one are ethical issues, and I talked a little bit about this on Monday, where it just seems kind of wrong to consciously give one group something that we think is going to help them and then deny it to other people. Obviously, to do something to a group of people that is potentially going to harm them is not something we really want the government to be involved with. So lots of times, policy experiments are actually funded and evaluated by private individuals. Um, there's a sort of famous example of Mike Bloomberg. You might remember that name, former mayor of New York, and he was very interested in what are known as conditional cash transfer programs, which is something that our own Ashu Honda in the Department of Public Policy and his students do a lot of research on, but in other countries. Because in the United States, they're seen as overly paternalistic. But the basic idea is you have something like education, and that you want kids going to school. Um, well, some kids need to work to make money for their family, or whatever other reason. So the theory is that if you give the family cash, if the student makes it to school X percentage of the time, then they're more likely to go to school, and the family is compensated for that time as well. And these things have been shown to be very successful in education with things like prenatal visits. Um, Anyhow, it's been almost impossible to get anything done like this in the United States. We don't really like these kinds of programs for some ideological reason. But Bloomberg put like $5 million or something of his own money and did an experiment with this in New York City. And unsurprisingly, it worked. And unsurprisingly, he still couldn't get the actual government to do anything with it. So, anyhow, ethical issues are a big part. There's just practical issues where it's impossible to randomly assign people, um, and other things that may come up. And then repeatability. Programs like this are expensive to implement, they're expensive to evaluate. And so there's not a lot of political will to fund them. And so you've seen this with, say, the soda taxes. I always call it a soda tax. I should be more technical. It's a sugary beverage tax. so it includes anything with added sugars. Um, but uh, there was an experiment in Philadelphia, showed reduction in consumption of soda, um, and yet other places haven't really wanted to do it. There's one in Mexico City, um, but repeatability can be difficult. And here's the thing about policy that makes this so important is the population of Philadelphia and the population of Mexico City are very different. And so it's likely you're going to get different results. Same thing's true with Philadelphia and Chapel Hill. Philadelphia and Portland. Whatever you want to talk about, when you have a country as large as ours and as diverse as ours, um, being able to set it up and consistently repeat experiments is very, very difficult. Okay. So, what do we do given that we're facing these barriers? Well, so we're going to go through a couple of strategies. The first one is called natural experiments, and it's important to understand that some people use this term in different ways. Generally, what we're talking about is something outside of our control happens that allows us to basically perform an experiment without setting it up in advance. Just something random happens. And the assignment to sort of, treatment and control group is at least approximating randomness. And so if we can take advantage of that selection process, then we can make causal claims, which again is the point. Some people define a natural experiment a little bit more broadly than I'm going to here, although it's still useful because we do this all the time in public policy. But it's a natural experiment that's also a time series or a multiple time series, or it's combined with some other form of evaluation. But, anytime the assignment of the population is out of control of the researcher, meaning who gets the treatment and who doesn't, that could be considered a natural experiment. But for it to be a good natural experiment, that assignment needs to be random, or as random as possible. A couple of examples here. I'll give you a little history lesson. Actually, one of the first and most famous natural experiments is actually the foundation of public health, kind of as we know it. And this occurred in London, where a researcher named John Snow, should have put a picture of John Snow, of Kit Harington on there, but oh well. What happened was a bunch of people were getting sick after drinking water from a particular well in the city of London, and this guy went and he mapped who was getting sick and dying, because hundreds of people died, and then he compared it to other places in the city where they primarily got their water from a different well, and figured out that the source of the illness was not just something in the air, but it was actually the water itself. But if you assume that the population surrounding the bad well and the population surrounding the good well are similar enough, then you can claim causation here. Anyhow, other ways that you see this, one of the first areas to enact a smoking ban in public places was Helena, Montana, which is a very sort of isolated place. And so they put in a policy banning it, and it lasted 6 months. And they saw that during that time, heart attacks in the city of Helena went down by 40%. Now, there could have been other stuff going on, but fortunately or unfortunately, There was a change in political control. The smoky ban went away, um, and heart attacks went back up again. Uh, that's pretty good evidence, but again, it's using time series data to show it. Um, One of my favorite kind of examples of this, that it's something that occurs naturally that then allows us to randomly assign people, is charter schools. So, charter schools are public schools that people apply to, either because they have a specialization of some kind or because they're just supposed to be better than whatever crappy school the kid currently goes to. Um, but remember, I talked about selection effect and selection bias. Uh, Parents of kids who are going to sign their kids up for charter schools are very likely to be systematically different than parents who don't. Um, so that is a problem. You can't just compare kids who go to charter schools to kids who don't. But once charter schools became popular enough and they started getting double the number of applications as there were spots available, then they could start randomly assigning kids. So half of them they let in the charter school, half of them they don't, and then they track both groups. You have a treatment and a control group right there. And that allowed researchers to make causal claims that were much stronger about the impacts of charter schools. Um, that has, to a large extent, driven some of the political left um, to really increase their advocacy against charter schools because the evidence was not positive. Um, but again, it is a natural situation of enough people applying that allows randomization that then allows us to make those direct causal claims. Okay, I spent probably too much time on that. All right, so let's go into some of the more sort of common evaluation strategies that we use. uh, the first is just called a non-equivalent control group, and really all of these have a non-equivalent control group. But the key thing to understand is we have to have a control group, right? There has to be a counterfactual. So if we can't get one randomly, we can try to pick one strategically, systematically. That minimizes the possibility of having some kind of confounding factors, that minimizes the possibility of bias. Um, and this is really where you start talking about representativeness of the population of interest. Are the treatment group and the control group both representative? Um, because that's absolutely necessary. So, what you're trying to do is identify the sort of key variables of interests. So, it could be some demographic category, race, ethnicity, age, gender, um, whatever. Um, and you want the two groups to be as similar as possible on those key variables. You know, um, because that's going to end up, minimizing selection effects. So, one of my favorite examples here is the flipped classroom. This is usually where I ask people how many of you have taken a class in a flipped classroom, and roughly half of you, or anybody that's taken Econ 101 or Bio 101, sort of raises your hands, and then I say, okay, how many of you liked it? And like two of you raise your hand. Uh, and yet it is becoming increasingly popular and seen as an effective teaching strategy. I personally am not convinced, um, and largely I'm not convinced because I haven't really seen the data to show that on average it is better. And the reason why is it's very, very hard to come up with a non equivalent control group that's adequate. Um, So if you just think about how this works, flipped classroom, right? I mean, it's almost like pandemic, but different. Um, they post lectures and things like that. You watch them asynchronously, you read stuff, and then you come to class and you talk about it. You do activities, you're applying it, and that kind of thing. And that's the theory, right? And it sounds great, but to know whether or not it works, um, a couple things pose problems. One is it the same teacher? Is that teacher as effective recording a video as doing a live lecture? Um, or the student's equivalent? That's the big thing. Um, you could randomly assign students to a flipped classroom and a non-flipped classroom, and you could have the same teacher do both of them. Um, but there's gonna end up being some threats of dropout and that kind of thing of people who get into the one that's flipped and they're like, no, and then they go and they sign up for the other one, or they just don't take the class that semester, or what have you. But it's very difficult to strategically get adequate treatment and control groups that are similar enough that you can make causal claims. Um, so. All right, let's talk about other things that are really, really common. Um, any kind of time series analysis. So this is using data across time, longitudinal data. And what it allows us to do is it allows us to use the same group of people as the treatment and the control. Okay? So you can imagine, a situation like the introduction of some policy where we have a population of interest. My example here is the Affordable Care Act and the uninsured rate, which I sort of previewed on Monday. But anything, the state level, local level, whatever you want, wherever you're doing it, you have that population, you have some intervention, and then you measure that same population again. And hopefully you can eliminate sort of rival causations and things like that, or at least show that there is some level of causation of that policy. So just to show you here an example, this is some data that I just pulled off Google, graph that I pulled off Google of looking at the percentage of U.S. adults without health insurance. And you can see, it's going back to 2008. So the year before President Obama took office. It had been rising well before that. It's still rising, it's rising. They actually signed it into law. Note that even after they sign it into the law, it still goes up because it hasn't been fully implemented yet. But then, okay, you get the exchanges open and you get the mandate. And boom, right? Big drop, another little drop, a little bit of leveling out. So, as long as you're looking at the same groups, as long as something else hasn't happened, some exogenous event, or even if it has, as long as it's happened to everyone, you can make a fairly solid causal claim that the Affordable Care Act reduced the percentage of uninsured from roughly 18 to about 11. That's pretty significant. Yeah. And so this is what we see a lot in public policy. Here are a couple of the problems. One, there might be some intervening event. And, we're living through an intervening event right now. The pandemic has totally messed up all kinds of research because all of a sudden the after group is very different. Now, I guess if you want to study the pandemic itself, say on educational outcomes, that's something that you could do. But let's say there's some educational program that was put in 2015, and you gather data all the way up, and then all of a sudden you get sort of early 2020, and nobody's in school. Um, that's just ruined your ability to do it. Now, you could argue that everyone is experiencing the pandemic, and therefore it may not, totally bias the results, but they're experiencing it in a way that's dropping educational outcomes across the board. And that is going to have a countervailing influence on whatever the policy was ahead of time. Prior to the pandemic, the classic example was 9/11. But things like that. If you're looking locally, any kind of natural disaster, those are going to severely limit your ability to gather appropriate data. There's also just a lag effect. It takes a while for the policies to kind of kick in and for the results to be seen. And as we talked about before, we have a very short run focus. And so we want some kind of immediate gratification of, bam, the policy's in place and the problem disappears. That's usually not the way it works. The ACA is a little bit of an exception there, that it dropped that rapidly. Whoops, I didn't mean to go back to it, but there you go. It is, dropping quite rapidly. Oh, now I got to go back through this whole thing. Okay. So that's another problem that you want to consider. All right. Sometimes can be useful, can be helpful to essentially do more time series analyses at the same time. And what I'm talking about here is including a separate non-random control group. This is especially applicable if you're looking at policies at the state level or at the local level, okay, where you can strategically select a non-equivalent control group and still use longitudinal data and look at changes over time, but you've got one state where the policy takes effect and one state where the policy doesn't take effect. In the Whelan book, there's a great example of this. I believe it was in Connecticut, where they were having lots of fatalities, driver fatalities. And so they implemented a policy that was just like total lockdown of anybody speeding got tickets and got big fines. So maybe not lockdown, it's a crackdown. Yeah. And so they looked at the data in the couple of years before, and then they had the crackdown, and they looked at the data the year after, and sure enough, there was a large reduction in the number of driving-related fatalities. That's great, okay? But there could be other things that caused it. It could be that the years in which it was really high, they were particularly cold, there was a lot of ice on the roads, whatever. So what they did was they looked at a state that was next door, that experienced similar weather events, but that didn't do the crackdown. And when you did that and you see that the number of fatalities doesn't change, well, that makes it a much stronger argument that the crackdown had a positive effect. Yeah. So the key is selecting a group of that is similar enough. Okay. I'm going to talk about this in a minute, but I'm going to pause the recording because I need to start office hours.